All right, next evidence, rapid sedimentation. So the Mount St. Helens eruption in Washington state produced 25 feet of finely layered sediment in a single afternoon. Now remember that evolutionists are telling you that the fine layers that you see in a geologic strata are the result of annualized rings at the annualized layers at the bottom of lakes, at the bottom of the oceans, processes that take millions and millions of years, and you just count up the thousands and thousands of fine layers, and you see that the rock layer must be millions of years old. So the problem is with things like Mount St. Helens happening and other areas, observations in river deltas also, where mud is coming in, being pushed down from a river out into the ocean, show that multi-layered sediments are formed simultaneously. They're not formed one layer upon another. They're formed as a process of the physical particles bumping up against each other while they're moving through water. So flume studies, and when you're talking about scientific theories, what you really need to depend upon is experimental evidence, right? That's what the scientific method is all about, doing experiments. So geologists have done flume studies where they mix different sized particles together and pour them out in huge operations, some of them very big, mimicking large scale floods, but in tight contained areas where they can film and use high speed film to see what's actually going on. So the physics of the self-sorting particle distribution that creates these multi-layers has been worked out. And if somebody's interested in it, and during the question and answer, I will explain it to you. It's not that difficult to understand how this happens. So we now recognize patterns. This has become so advanced in art that you can recognize patterns in the strata laid by floodwaters that tell you how fast the water was moving and how deep it was above the where the strata was being laid down and the direction of flow. So this is really amazing. So you can point out to take a strata layer in the Grand Canyon, and by examining the layers and how they're laid down, you can tell how fast the water was moving and how deep it is. And it'll be, I've seen these reports, and there are things like 2,000 meters of water above and flowing at 60 miles per hour, things like that. All of this can be determined because we now know the physics of the particle motion in flooding water. In one experiment, finely layered sedimentary rocks, so they created it artificially with particles they put together themselves. Then they decided, well, let's take already sedimentary rock that's been laid out, crush it down to its constituent particles, mix it with water, and send it down the flume and see what happens. And it creates the exact same lamination patterns that were found in the original rocks. So this is completely repeatable, which gives the obvious conclusion that that is how those rocks were created in the first place, through a massive flood. All right, and through the self-sorting mechanism that just is what happens to particles when they're in floods conditions. So this was published in the prestigious scientific journal Nature, Spontaneous Stratification in Granular Mixtures. So here is the preeminent science journal publishing the evidence that shows that actually the Earth is young. Here's some photographs. These are from these sedimentary experiments. So you can see these fine, this is, I apologize for the quality of this picture, but you can see the fine grained strata going across this. This is, the flume is going north and south, right? The flume with clear walls is going north and south. And they've cut into this and pulled back the sediment so that you can see it. And you see this layering that's happening that looks just like strata that you might see driving through maybe the Delaware water gap. Now here you see it from the side wall, looking through the plexiglass wall, and it's going right and left. And you've got 15 centimeters of sand. So this was particles where black was larger particles and white was smaller particles. And see how it goes white, black, white, black, white, black, white. And you get a large area of black and a large area of white, black, white, black, white, black. And that tells you, by this lamination, this tells you how much water is above it, how much water is above it. And if you notice in the black, these slanted, these are called bedding planes. And this you see, once you know this, you can read the rocks. Like when I visited Sedona, I was able to read the rocks to people. We were, on tour, and, people are hiking through, and we, say, hey, okay, look, you can see which way the water was flowing. So in this case, because of the direction of these bedding planes, you can tell that the water was flowing from the right to the left. Right? Isn't that cool? All right. Let's see. Let me continue on. So experiments show that strata form simultaneously in moving water. I already said that. And this has been confirmed by observation at river deltas, but it's also been confirmed by observations in deep ocean drilling. So they'll have things that happen called underwater avalanches, where off the coast of a continent, massive amounts, millions of tons of debris and soil will come loose and will stream down the bottom to the bottom of the ocean. That all leaves these finely striated layers, just like you find in places like the Grand Canyon. So, all right. So now in this experiment, let me ask you a question. Where are the oldest layers? Where are the oldest layers? Are they down here? Are they up here?
Towards the bottom, like where it's pointing.
Okay, right. Well, that's what we think when we see things like the Grand Canyon, right? You think, well, the oldest must be on the bottom. But remember, this was done simultaneously, right? These layers all happened simultaneously. It was done within like a minute, right? It was just poured out into this flume. The oldest layers, remember the direction of the water is from right to left. The oldest layers are on the right, and the youngest layers are on the left. That's how you have to actually read strata, because of what we know through experimentation. So what do we have around the world? Oh, let me close out. I don't know if those controls are in your way, but I see them. So we see strata, for instance, the Grand Canyon, all around the world. Rock layers cover entire continents, and these same rock layers can be traced over to other continents, which we're going to get into more in a few minutes. Let me pop back on that. There we go. Notice the razor sharp edges, right? They're just completely level, time after time after time. And from the top of the Grand Canyon to the bottom of the Grand Canyon in this picture, This supposedly covers a time period of 500 million years. And yet you see nothing to confirm that, right? We're looking at erosion, right? We see how erosion is cut through 500 million years worth of rock, supposedly, right? Where are the roots of trees? Where are they? Why don't any of the layers have any trees? Did no trees ever grow here for 500 million years? Why are there no animal burrows? Did no animals ever dig into the ground during this time? There are plenty of dead animals in this, right? Billions, in fact, billions of fossils of dead animals that were consumed by this massive flood. None of them were alive to burrow into any of these layers. There's no erosion, right, except for from today, right, from after it was laid down, then it erodes away. But where is the Little Grand Canyon? Let's go up 1/3 of the way, right? 150 million years since the beginning, since the bottom, right? Where is the Grand Canyon there? Where is the erosion of any canyon at all? There are none, right? There are none. Did nothing ever erode for 500 million years? There's no earthquake evidence, right? You will see earthquake evidence from the top all the way through the bottom, but that's not what we'd be looking for. Where's the earthquake that happened, the massive earthquake that happened, 400 million years ago that cracked the bottom 100 million years? Where's that crack? Or 2/3 of the way through, 200 million years later, when there's another massive earthquake that cracks it down from top to bottom of what was then the top, right? There are none. And yet today we find lots of places where there are earthquake cracks that go all the way through all of them. And that's because all the layers were laid down simultaneously. We also know that they were soft, right? They were bendable. If this bend had been done to rock layers that were solidified already, that the water and moisture had been pressed out of them already, they would have metamorphed, right, from the pressure, and they would have cracked, right? And you could look microscopically at the grains of the rock, and they would be elongated, right? Because there would be so much pressure to bend rock like this. But this was obviously bent while it was still soft. And yet this is supposed to be millions of years worth of layering. Here's another example of soft layers. Now, this takes a little bit of imagination. I have to explain to you what's on the other side. On the other side of this is dinosaur tracks, okay? So if you walk up this kind of incline from the other side, you're looking at the back edge of it that has been cut away and broken away. There are dinosaurs, and you see in the mud, the dinosaurs have stepped and pressed footprints into the mud. This, by the way, this person is Dr. Robert Carter. Dr. Carter and I will be going to Egypt in September to investigate the Egyptian gods that are dedicated to the first 8 people, or gods, the first 8 gods that created the earth out of a watery chaos. Right? Does that sound familiar? 8 people on a boat. And so those are the first gods that the Egyptians worshipped. Anyway, so he is on the other side of this. So this lump, let me go back to my annotation and get my little laser pointer. Okay. So in the back, on the other side of this, the top layers have broken away, eroded away, and been removed. And only this layer and everything below it is visible. And what is this here? This is a dinosaur footprint. And then the rock layer continues over this way. All of this above stuff on the other side is missing, and that's where you see the trackways. So this continues on. The dinosaur keeps walking. He steps and creates this hole in the mud. And then the next layer, after he goes away, the next layer comes in of floodwaters and fills in the footprint and that layer. And that's what preserved all these footprints. On the other side, they've broken away and fallen out on this side, but take a look at how deflected the bottom layers are underneath the weight of that dinosaur. See how curved they are? All of these layers were soft. Even this one you can see is bent by the weight of that dinosaur. He curved all these layers all the way up to here just by the weight of his foot. And it shows that all these layers were soft, and yet here they are. This would represent certainly hundreds of thousands of years based on traditional geologic reading.